Hello students, this is a video on the topic tests for quant available on the BodhiPrep Android app. The basic idea of these tests is that once you've covered the basic concepts of a topic, you can take this test to understand whether you're able to apply the learned concepts in a test or a exam format or not. With every test, there is a video. So once you've taken the test, refer to the video. It gives you the solutions, number one, and number two, a brief analysis of the kind of questions in terms of number and time that you should have spent for a good attempt in this kind of a test. And there are more than 200 topic tests available on the BodhiPrep Android app. The link for the app is in the description, so you can download the app and make the most of these tests. There are multiple tests available on each topic. This video specifically is about progressions, and we're discussing test number 3 on progressions. Overall, the test was moderate level of difficulty, 6 to 7 questions net correct, would give you a 95 percentile plus for sure in a test like this. And the attempt time would be somewhere around 20 to 22 minutes. The idea is 20 to 22 minutes to go through the entire test and get the 6 to 7 questions net that we are looking for our percentile. If we look at the questions, question 1 says A1 plus A2 plus A3 up to AN is 3 into 2 raised to power n plus 1 minus 2. We have to find A11. Now A1 will be nothing but 3 into 2 raised to power 1 plus 1, which is 2 raised to power 2, 4 minus 2 into 3, which is 6. A1 plus A2 would be 3 into 2 raised to power 2 plus 1 minus 2. 2 cube 8 minus 2, 6 into 3, 18, which means 6 plus A2 is equal to 18, which means A2 is equal to 12. A1 plus A2 plus A3. Basically, we're trying to look for a pattern which we can using which we can make a general term 3 raised to power 2 raised to power 3 plus 1 minus 2, 2 raised to power 4 is 16 minus 2, 14 into 3, 42. So 6 plus 8, 12 plus E3 is 42. 42. 18 minus 42, this implies A3. A3 is 24. 6, 12, 24. So basically the terms are doubling. We will just check for A4 just to be sure. 3 into 2 raised to power 4, 4 plus 1. 32 minus 2, 30 into 3, 90. 6 plus 18 plus 24 plus A4 is 90. 24, 30, 12, 12, 12. 24, 30, 42. 90 minus 42 will give us 48. So very clearly the terms are A1 being 6, A2 being 12, 6 into 2, A3 being 24, 12 into 2, A4 being 48, 24 into 2 and so on. Therefore, we can say 2 is being multiplied. The general term is A1 can be written as 3 into 2 raised to power 1. A2 can be written as 3 into 2 raised to power 2 and so on. Therefore, A11 will simply be, this is 2 raised to power 3 into 3. A11 will be 3 into 2 raised to power 11. 2 raised to power 11 is 1024 into 2, which is 2048. And therefore, so this becomes 120, 144, 6144 becomes the value of A11. Again, just putting values and solving is what we did. The pattern was pretty simple, but attempt time might be a little high. So 2.5 to 3 minutes to attempt the question, and level of difficulty H is moderate because there are chances of maybe a calculation mistake happening or things like that. Otherwise, the process remains standard for this type of a question. 1 upon 1 factorial, 19 factorial, 1 upon 3, 17 factorial, 1 upon 5, 15 factorial, and so on. Is 2 raised to power a upon b factorial. What is sum of a and b? 1 and 19 is 20, 3 and 17 is 25, and 15 is 20, and so on. Therefore, if we divide and multiply the left hand side with 20 factorial, we will get this value. 20 factorial upon 3 factorial, 17 factorial, 20 factorial upon 5 factorial, 15 factorial, 20 factorial upon 19 factorial, 1 factorial. Now, this can be written as simply 20C1, this is 20C3, this is 20C5, and so on. This is 20C19. These are the terms of the odd terms, basically. Now we know that NC0 plus NC1 plus NC2 till NCN is nothing but 2 raised to power n, uh, because this is the expansion of x plus 1 raised to power n. Put x is equal to 1, we get 2 raised to power n. If you put x is equal to minus 1, we will get NC0 minus NC1 minus plus NC2 minus NC3 and so on till NCN minus 1 raised to power n NCN. This will be equal to 0. So if we subtract this equation from this equation, we will get twice of NC1 plus NC3 plus NC5 and so on, depending on the value of n minus 1, all the odd terms basically, as 2 raised to power n minus 0 divided by 2, and therefore NC1 or the sum of odd terms simply is 2 raised to power n minus 1. And therefore this can be written as, now this is part of something that we do in permutation combination, binomial expansion. So this further becomes, n is 20 here, so the numerator will be 2 raised to power 20 minus 1 upon 20 factorial, which means 2 raised to power 19 upon 20 factorial. This is given to be as 2 raised to power a by b factorial. Therefore, a is 19, b is 20. We have to find the sum of a and b, which will come out to 39. Option D becomes the answer. Again, if you have done a question earlier like this, then I'll say a moderate level of difficulty question. If you've not come across a question like this, or we do not understand the concept of NCR, then definitely a difficult question, and attempt time also for this question would be on the higher side. A1 into A3, A4 up to A31 is in arithmetic progression. A1, 7, 13, 19, 25, 31 is 372. Find the value of A16. First of all, from A1 to A31, if we look at it, the term in the center will be A1 plus A31 upon 2, which is A16, 13 plus 1 by 2. Also, if you look at it, A1 plus A31, 32, A7 plus A25, 7 plus 25, 32, A13 plus A19, 13 plus 19, 32. All of them will have the same sum. So we can see this is nothing but 3 pairs, and therefore 3 into A1 plus A31 is 372. We want to find A16, so divide by 6 on both sides. A1 into A31, 3 by 6 is equal to 372 by 6. This becomes 3 by 2. A1 plus A31 by 2 will be A16, the term in the center. 372 by 6 becomes 6, 6 is 36, 62. And therefore, option B becomes the answer. Easy question. Just arranging the terms, not more than a minute and a half to solve this. From the first 20 natural numbers, how many arithmetic progression of 5 terms can be found such that common difference is a factor of the 5th term? Now, common difference could be 1. In this case, we could have arithmetic progression starting from 1, 1, 2, 3, 4, 5, 5 terms, 2, 3, 4, 5, 6, and so on. The last arithmetic progression will start from 16, 16, 17, 18, 19, 20. These are 16 progressions. D, if we put as 2, if we start with an odd number 1, the last number will also be odd. And therefore 2 will not be a factor of the 5th term. Therefore, we have to start with even numbers. 2, 4, 6, 8, 10. 10, 2 is a factor of 10. 4, 6, 8, 10, 12. 12 is a factor, 4 is a factor of 12. 6, 8, 10, 12, 18. 18 is a factor of, 6 is a factor of 18. 8, 10, 12. Oh, sorry, I've skipped numbers here. 14, 16. 6, 8, 10, 12, 14. Common difference is a factor of the fifth term. Common difference is a factor of the fifth term. Okay, we don't have to check. We're not checking for the first term, sorry. We're just checking for common difference. Since we are starting with D as an even number, the last number will always even, so a factor. With D as 2, we have to start with even numbers. The first term could be 2, 4, 6, 8, 10, and the last series will be 12. 12, 14, 16, 18, 20. In all of these cases, 1, 2, 3, 4, 5. In all of these cases, the last term will be divisible by the common difference, that is 2. Therefore, the number of series possible is 1 starting from 2, 4, 6, starting with 8, starting with 10, starting with 12. So 6 series are there. Then we look at D is equal to 3. If we start with 1, we'll have 1, 4, 7. Clearly, since 1 is not divisible by 3, adding 3 will not give us a number that is divisible by 3. So with 3, we'll have to start with 3 itself. 3, 6, 9, 12, 18, 15. The next series could be multiple of 6. So 6, 9, 12, 15, 18. Then if we go for 9, starting with 9, we'll have 9, 12, 15, 18, 21, which will not be the first 20 numbers. So there are 2 series possible. If D is 4 and we start with 2, 2, 4, 2, 6, 10, 14, 18. In this case, 18 is not divisible by 4, so this will not be a possible series. But we can start with 4 and get 4, 8, 10, 12, 10, 4, oh, sorry, I'm bringing a difference of 2. 4, 8, 12. 4, 8, 12, 16, 20. This will be the only series with a common difference of 4. If you look at common difference of 5, 5, 10, 15, 20, 25 will not be in the first 20 numbers. And therefore, these are the total series possible. 16, 6, 22 plus 3, 25 APs are possible, which have 5 terms, and the common difference is a factor of the fifth term. I think moderate to difficult level of question, a very high chance of an error happening. And therefore, the attempt time, since we are counting cases, the attempt time will also be on the higher side, 2.5 to 3 minutes. Mr. and Mrs. Chaudhary have 2 sons and a daughter. The daughter is the youngest among the 3 children. Mrs. Chaudhary is 5 years younger than Mr. Chaudhary. The age of the children form an arithmetic progression. Common difference is 1. So if the age of the daughter is X, the age of the sons will be X plus 1 and X plus 2. If Mrs. Chaudhary is Y years old, Mr. Chaudhary is 5 years older, therefore Y plus 5. Mrs. Chaudhary is 5 years younger than Mr. Chaudhary. The sum of the ages of the male members. Male members will be Mr. Chaudhary Y plus 5 plus the sons X plus 1 and X plus 2. This is given as 92, which means Y plus 2X is equal to 5, 6, 7, 8. 84. Female members of the family is 67. So Y plus X is equal to 67. This is equation 1. This is equation 2. What is the sum of the ages of Mr. and Mrs. Chaudhary? 2Y plus 5. Now, if we subtract 2 from 1, we'll get X is equal to 17, 84 minus 67. And from there, we can say Y is equal to 50. Putting 17 here, we'll get Y as 50. We have to find the sum of ages of Mr. and Mrs. Chaudhary. So the sum of the age of Mrs. Chaudhary is 50. Mr. Chaudhary will be 55. And therefore, the sum of ages 50 plus 55 or 105 should be the answer. Therefore, none of these. I think an easy question should not take more than about a minute and a half to 2 minutes to solve. Definitely something that should be done in the Kirti had to calculate the sum of 8 consecutive integers. However, 8. However, she added one of the numbers twice by mistake and obtained 1295. So this is the sum of 9 numbers consecutive. Find the number that Kirti added twice. Now suppose the number she was supposed to add was A a plus 1, a plus 2, a plus 3, a plus 4, 5, a plus 6, a plus 7. These are the 8 numbers you were supposed to add, 8 consecutive integers. Therefore, the sum that she should have gotten was 8a plus 7, 6, 5 term is missing. 1, 2, 3, 4, 5, 6, 7. A5 will also be. So 1 plus 2, 3 plus 3, 6 plus 4, 10, 15, 21, 28. This is what she should have gotten. She ended up adding one more term from these. One of the numbers is added twice. Now, if we look at 1, 2, 9, 5, 5, 6, 7, 8, 5, 8 divided by 9, this gives us a remainder of 8. Now, if I am to add one of these terms, it will be of the form a plus something out of 0, 1, 2, 3, 4, 5, 6, 7. So we'll have 9a plus 20, 9a plus 28 plus something. Now, 9a is divisible by 9. So to get a number which is of the form 1295, the remainder from the remaining part should be 8. If we add the digits to 20, now 9 divided by 28 gives us a remainder of 1, 27 plus 1. So we need to add 7 to this. So if we add a plus 7 to this, we'll get not 7. We get a remainder of 8. 35. Yeah. So 9a plus 35. This is the only possibility where by dividing by 9, we get a number which has a remainder of 8. If we added a plus 1, this will be 29, which will give us a remainder of 2. With 2, we will have 30, remainder of 3, 4, 5, 6, 7, 8. And therefore, a plus 7 gets added twice. And therefore, the total that Kirti has is 9a plus 35, which is equal to 1295. So 9a is equal to 1260. And therefore, a is equal to 9 ones are 9, 140. The numbers that were supposed to get added were 140 to 147. And Kirti ended up adding a plus 7 twice. And therefore, the number added twice is 147. We could also have approximated by saying that 1295 is the sum of 9 numbers. So the numbers are around 140, 150. That is 1295 upon 9. This will give us the number in the center. From there, we can approximate and see which series is being added and what is the number using the calculator in the exam. But I think this approach is more efficient in that sense, and we get a definitive answer. Overall, I'd say moderate level of question. If cracked properly, looking at 9 and the remainder, should not take about more than 2 to 2.5 minutes. The sum of the first 4 terms of an AP is 1/5. The sum of the first 9 terms of an AP. What is the ratio of the first term of the AP to the common difference? Sum of 4 terms would be A plus D plus A plus 2D plus A plus 3D. 1, 2, 3, 4 terms. So 4A plus D, 2D, 6D. Sum of 9 terms would be A plus D plus A plus 2D. And so until A plus 8D. This will be 9 A's. And for D, we'll have D, 2D, 3D, 4D up to 8. 1 plus 2 plus 3, 6 plus 4, 10. Plus 5, 15, 21, 28, 36. 9A plus 36D. 1, 2, 3, 4, 5, 6, 7, 8. Added is 36. It is given that the sum of the first 4 terms, 4A plus 6D, is 1/5 of the sum of the first 9 terms, 9A plus 36D. What is the ratio of the first term and the first of the AP to the common? A by D is to be found out. So 20A plus 30D is equal to 9A plus 36D, which means 11A is equal to 6D, which means A by D. D goes down, so 6 comes down. 6 upon 11, option D becomes the answer. Ratio of first term to common difference, A by D is 6 by 11. I think easy to moderate sort of a question. Just put the values. Even if you write the formula for the sum of an AP and equate, we'll still get the same answer. In similar amount of time, that is I'm trying to say, about 2 minutes to solve the question. The sum of the 4th and the 20th term of an arithmetic progression is equals the sum of the 6th, 12th, and 16th term. Which term of the progression is necessarily 0? A plus 3d, 4th term, plus A plus 19d, 20th term, is equal to A plus 5d, 6th term, plus A plus 11d, A plus n minus 1d, 12th term, plus A plus 15d. These two sums are equal, therefore 2A plus 22d is equal to 3A plus 15, 26, 26 and 5, 31d, which means A plus 9d is equal to 0, which is nothing but A plus 10 minus 1d is 0. Which term of the progression is necessarily 0? Here n is 10, so the 10th term of the arithmetic progression is 0. Option B becomes my answer. Again, I think easy to moderate level of question, not more than 2 minutes to solve the question. The first and last term of an arithmetic progression having at least 3 terms are 5 and 25. First and last term are 5 and 25, and there have to be at least 3 terms. If all the terms of this arithmetic progression are integers, find the different values that the common difference of the arithmetic progression can take. Now, clearly D could be 1, in which case we will have a series which is 5, 6, 7, 8, 9, and so on till 25. D could be 2, because we're starting with an odd number, and if we add odd number 5, 7, 9, 11, 13, we will end with 25, not a problem. If you look at DS3, 5 divided by 3 is a remainder of 2. 25 divided by 3 is a difference of 1. So adding 3s will not reach 5. If we add 4, or rather, other way of looking at it could be the difference between 5 and 25 is 20. 20 is divisible by 1, 2, 4, 5, and 10, and 20, of course. 2 square into 5, 6, 5. As long as D is one of these values, we will get the first term as 5 and the last term as 25. The only thing is when D is 20, in that case, there will be only 2 terms, 5 and 25. So this will not be counted because we need at least 3 terms. So D can get one of these 5 values. 1, 2, D could be 4, in which case we would start with 5, 9, 13, end up with 25. D could be 5, in which case we'll start with 5, 10, 15, end up with 25. And D could be 10. In this case, we'll have 5, 15, and 25, so exactly 3 terms. So D can take these 5 values, basically values where the difference is divisible by the number, or the factor of the difference between the first and the last term are the values that D can take. So 5 becomes my answer. Again, easy question, might take a bit of time to just get cracking. But once you see the pattern of 1, 2, 4, it becomes pretty obvious in about 1.5 to 2 minutes to solve the question. The letters of the English alphabet in the order A to Z are made to represent 26 numbers which are in arithmetic progression. The sum of the numbers of A, C, E, G. Okay. A, B, C, D, E, F, G, H. These are the numbers in question. The sum of A, C, and E. Now, if this is X, this will be X plus 2D. This is X plus D. This would be X plus 4D, X plus 3D, X plus 5D, X plus 6D, X plus 7. ACE is A plus C plus E is 36. A plus C plus E plus G is 60. So if we subtract 36 from 60, we'll get G is equal to 24. So X plus 6D is equal to 24. If we look at A plus C plus E, that will be X plus 2D, A plus C plus E, X plus 4D, which means this is 60, this is 36, which means 3X plus 6D, 4, 5, 6. 3X plus 6D is 36 divided by 3. X plus 2D is equal to 12. Subtracting this equation from this one, which was for G, X plus 6D is 24, we will get x minus x, 6d minus 4d is equal to 12, d is equal to 3. And therefore, we can subtract 3 from each of the terms. 24 minus 3, 21, minus 3, 18, minus 3, 15, minus 3, 12, minus 3, 9, minus 3, 6. 6, 12, 18, 18, 36, that's it. What is now the numbers representing B, D, F, H? H will be 27 plus 3. So B is 9, D is 15, F is 21, H is 27. B, D, F, H. 9 plus 15, 24, 24 and 21, 45, 45 and 27. 65, 72. Option C becomes the answer. 30, 45, 65, 72. Again, I'd say easy to moderate sort of a question, should not take more than 2 minutes to solve, because at the end of the day, there are just two equations that we are solving for the first term and the last term. So from there, I think this question becomes uh, easy to moderate in terms of level of difficulty. So if you look at the overall test, moderate level of difficulty, 6 to 7 questions net required, 20 minutes or time to attempt. The questions that I would look at for my 7 questions would be 1, 3, 4, 5, 7, 8, 9. Which are these? Would be attempting this for the simple reason that the pattern was pretty simple. It is a multiple of 2, so not very difficult to extrapolate. Not counting this, not everyone might be comfortable with combination. We would be doing this. All we had to do was divide 372 by 6, so easy question. This one also not a difficult question. Easy cases were to be formed with D 1, 2, 3, 4, and so on. This again was a simple equation question, should have been attempted. This one I think can get tricky if you're not able to crack the fact that remainder with 9 is 8. We'll have to make cases. So I'm not counting this as an easy question or attempt question. This I think was pretty simple. Just write the formula on both sides and equate. Similarly, here we are getting the clear term a plus 90 is 0, so not very difficult to solve. This also I think was easy because once you realize that 20 is the difference, factors become pretty obvious. Just make sure that we don't end up counting 20 as the common difference. So I'm counting this as an attempt question. This again was not very difficult to solve, but there are chances of calculation error happening. And since I'm looking at 7 easiest ones, maybe this is not a question that I would count. So overall, I'm saying 1, 3, 4, 7, 8, 9 will give me my 7 questions correct.